In this demo, we want to show how edge cloud architecture combined with strong engineering and the right methodology enables systems that simply do not stop even during a disaster. We have a demo application running at gslb-demo.rng.academy. This application is running in an active architecture across two data centers, Munich and Frankfurt. When we refresh the page, traffic is routed randomly to one of these two locations. Sometimes the response comes from Munich, sometimes from Frankfurt. Let's refresh. Now we got response from Frankfurt, Munich, Frankfurt, Munich. It's totally 50%. So, even though this looks like a simple web page, behind the scenes, it is a Kubernetes-based application running in two locations. And in this demo, each location is running a single node Kubernetes setup. What you see on the screen is exactly that. The active region, Kubernetes pod information, and live runtime details. So, why are we showing this demo? Because our goal is not just to build systems that scale. Our goal is to design systems that continue running during disasters. Today, data loss is considered a disaster, but in modern digital systems, downtime itself is also a disaster, especially for systems that are expected to run 24/7. And this is exactly the problem edge cloud architectures are designed to solve. So, now let's simulate a real disaster scenario. You can think of this as anything: a fire, a flood, a power outage, a cyber attack, it doesn't matter. In this demo, we connect to the Munich Zadara Edge Cloud and we intentionally power off the Kubernetes environment and Munich. And it's important to say this clearly. This demo is not limited to Kubernetes. The same methodology applies to IaaS, Nginx, traditional virtual machines, or any other application stack. This is not about a specific technology. This is about architecture and methodology. So let's power off the Munich. As you can see, we have single node Kubernetes cluster in Munich. Then let's power off. So let's try to access application again. Page still loading because health checks are still being made and it can take 15 to 20 seconds. And as you can see, even Munich is down, application continues to work without any manual intervention. From the end user's point of view, the application is still accessible, the page still loads, the service still available. There is no system is down message, no manual failover, no emergency operation. Even though one entire data center is unavailable, the system continues to operate. This is what true resilience looks like. And this is where edge cloud architecture and engineering disciplines come together. Because the goal is not just to recover after a disaster. The real goal is continue serving users while the disaster is happening. For many organizations today, downtime means revenue loss. Downtime means reputational damage. Downtime means broken customer trust. And in sectors like finance, e-commerce, public services, SaaS, even minutes of downtime can have a serious consequences. With this approach, there is no single point of failure. Failover is automatic and users are not affected. That is the difference between traditional architectures and modern edge cloud designs. This demo shows that with the right architecture and methodology, you can build systems that do not stop even when parts of the infrastructure fail. And this is exactly what we designed with Zadara Edge Cloud and our engineering approach. Always on systems built for real world failures.